Yes, sir.
Good afternoon. How are you?
I'm fine, sir. How are you?
Alhamdulillah, I'm also fine. Lamisa, Mariam,
Yes, sir.
Ramadan Kareem.
Thank you, sir. You too.
Yeah. So we did it in last class. Domains. Domains are tiny magnets. What are the basic structures of magnetic materials? Why magnetic materials are magnetic materials? The reason because they contain domains. Okay, and these domains are not arranged in a particular direction primarily. When they are magnetized, the magnetic materials are magnetized, then the domains are arranged in a regular pattern. Okay, that diagram we are showing here, we have here domains, you see, randomly aligned in magnetic materials, and here are domains aligned with external field. External field means magnetic field that can be from any magnet, permanent magnet, or that is from any uh, DC current, or that is by stroking method we can have it, right? By induced magnetism, by stroking, by DC power supply, we can make magnet. We can magnetize the magnetic material. So here we have more. You see, we have some more diagrams here. Image 3, that is also the discussion we are doing or we did on domains. We also have another one, this one, on domains. Then we have in our class, we also got methods of demagnetization, hammering, heating, and passing AC, right? So if we are doing any of these three, then the regular arrangement of the domains it becomes distorted. Then the magnet loses magnetism, and this process is called demagnetization. So there are three processes we got, and here we have explanation of these three processes here. When we hammer a magnet with a strong force or heat the magnet at a high temperature or withdraw the magnet slowly through a solenoid containing AC. AC means alternating current. In all cases, magnet loses its domain's regular arrangement, which leads to demagnetization. So learn it. Then we have all the demagnetization process. Heating and hammering is very easy to understand, and here how we are using AC to demagnetize a magnet. Okay. Then we have soft and hard magnetic materials. There are examples, and soft magnetic materials they are used for using or making temporary magnets. Temporary magnets example: electric bells, circuit breakers, relay circuit, reed switch. Then we have finally hard magnetic materials. Examples: Hard magnetic materials are used for making permanent magnets. So hope all of you got it right. They who even missed the class, if you go through these notes, inshallah you'll understand, right? I think you already went through, except Lamisa, you all went through. And Lamisa got it in 2019 also this notes, so she knew it before. And also we have the video here, okay? So you go through this here. Now let us go to the learning outcomes again. Let's see what is left over there, then we can go forward. So A, B, C, D, we are done with. Now we have E and F also. F, G, these two are also done, like temporary magnets, permanent magnets, they're examples. We had the idea. Temporary magnets, they are made from soft magnetic materials and they lose their magnetism if the conditions are removed. That's why they're temporary magnets. Permanent magnets, they retain their magnetism even if the conditions are removed. And we got the uses of permanent magnets, and electromagnets means temporary magnets. So electromagnets, we got here uses: electric bell, the circuit breaker, reed switch. These are the uses of electromagnets. Okay, now we have here describe the plotting of magnetic field lines with a compass. This one will do. This is also known as plotting compass. In short, it's called plotting compass. So how does it work? We'll try to understand. And before going to this one, we will have two more ideas. One is what is called magnetic field and properties of magnetic field lines. These two things we'll do, then we'll come for plotting compass. Yeah, Mahi. Hello, Mahi.
Yes, Assalamu alaikum, sir.
Alaikum salam. Ramadan Kareem. Mahi, how are you?
Fine, sir. How are you, sir?
Alhamdulillah. We are also fine. Magnetic field, right?
Yes, sir.
So field, this term is very specific. That means the region or the place or the area where the magnetic effect works. Like we can think of, you also got it in your uh, life, this experience that when we take a magnet closer to a magnetic material, it attracts, right? Like you are sitting on a table and there you are keeping the permanent magnet, and the magnetic materials you are keeping for example, 100 centimeter away, that is 1 meter. And when you keep it there, the magnetic, like some small paper clips or nails you are keeping, then you'll see that magnetic force is not working over there. It's not attracting the nails or paper clips. But if you are bringing them closer, like very close, 5 centimeter away, then you'll see the paper clips are jumping to be attracted to the magnets, isn't it? Have you understood, everyone? Hello.
Yes, sir.
Yes,
So,
sir.
why is happening? The reason is the magnetic force. It has a range, right? It does not work for unlimited range. That much is stronger. There might be some field lines over there, or field is there, but that's not so strong that you can observe there is magnetic field or force is working. So the region where the attractive force is working, that is called magnetic field. Is it clear, everyone? So we write here what is magnetic field. So today's date we'll write also. Topic 17 continued. Yeah? Topic 17 continued. Year 15 for 21. The region which uh, magnet magnet experiences its attractive or repulsive force. Properties of magnetic field lines. Around a magnet, around a magnet, we observe some field lines connected between north and south. south pole, which have three important properties. As given below. Number one, magnetic field lines start from North Pole and and the South Pole. Number two, magnetic field lines are closer at the poles, and that's why magnetic force is strongest at the poles. Then number three, magnetic field lines never cross over each other. I'm showing you the explanation with diagram. So you write it, finish writing.
Sir, done.
Very good. I'm also sending it in the group. Today is a wonderful day that we got all our participants, right? All the students are present today, right? Yeah. April. Today is 15. Today is 15. Yes. Yes. We are showing you from the real life experience first. You might have this idea or this experience before. Magnetic field lines, and iron filings. Yeah, this one we see here. If you are taking some iron filings and you spread them on a white paper, you keep one iron bar over there. Yeah, sorry, magnetic bar, magnet, that is called bar magnet over there. You see the lines around the magnet. See, lines are created north to south. Uh, and you see most of the iron filings are attracted to the poles, right? Which shows
Yes,
that
sir.
which shows us that the magnetic force is strongest at the poles. And the reason behind is the field lines, they are closest at the poles. So from this observation, we understand two things. One is magnetic field lines are closer at the poles, and magnetic field lines, as they are closer at the poles, the magnetic force is strongest at the poles. These two things you understand from this field or this observation we understand here. And the other two things, magnetic field lines never cross over, or magnetic field lines start at north and end to the south. For that one, we understand from plotting compass. We understand it from plotting compass. So we will go for plotting compass also. Before that, we are going for magnetic field lines. How to draw? Okay, so you see magnetic field lines. Are you seeing everyone?
Yes, sir.
Yes, sir.
This one is much better. Huh? You draw this one. So you draw north south pole, and the field lines you draw around the magnet this way. The arrow direction, those are coming out. The field lines which are coming out from the north pole, you see the arrow direction is showing, and going inside the south pole inwards, right? This direction inwards. So you draw it, huh? Everyone. This one you have to draw. I sent you in the group. This one also I'm sending in the group, but this one you do not need to draw. Okay. Plotting compass. You all know about compass, right?
Yes,
Hello.
sir.
Yeah. So this compass is used to get the direction of magnetic field lines. We become sure about the direction that it starts from the north and into the south from the plotting compass. From the iron filings, you only understand the shape of the magnetic field lines, but from plotting compass, we can also have the direction. To get magnetic field lines pattern, field lines pattern, only we we use iron filings. However, by using plotting compass cause technique, we can find the magnetic field pattern and their direction as well. Do so, we use three following steps. Number one, keep the compass closer to the poles and sideways at several places. Then observe the observe observe the direction of compasses of north pole. We have 1 minute, right? We have 1 minute left, so the next two steps we'll do later. Huh?
Okay, sir.
Next meeting you join after 5 6 minutes. Huh?
Okay, sir.
3:58 you join.